The ADC Telemetry-based Autoscaling solution provides an example of how you may configure and manage consistent scaling of both F5 Big IP and backend workload application clusters across multiple public clouds. The solution is deployed via Terraform. The deployed environment consists of a Big IP cluster, a backend workload cluster, and a HashiCorp console server. The console server provides workload service discovery as well as remote state management for the infrastructure itself. A third-party analytics provider, Splunk for this example, ingests Big IP telemetry data via F5's telemetry streaming service. Alerts can be configured in the third-party provider based on a variety of events and metrics to trigger scaling of both the ADC and the workload clusters. Alert messages are proxied via a webhook call to the alert forwarder service, which normalizes and securely triggers the automation workflow. The solution utilizes GitHub Actions for automation and the automation workflows. The workflow makes use of the shared Terraform state and information stored on the console server to perform scaling operations automatically. Since the solution makes use of GitHub Actions, I must first duplicate the repository into a GitHub account where I have administrative control and am able to create and use a GitHub personal access token. To start, I first create an empty repository under my GitHub account that will host the solution files. With the repo created, I'll use a terminal window to create a bearer clone of the F5 Dev Central hosted solution repository. Next, I push a mirrored copy of that local clone that I just made to the empty repository that I previously created. With that done, I can now delete the local clone. Prior to deploying the solution for my repo, I must also create a few GitHub secrets. These secrets include a copy of my GitHub access token, as well as the relevant cloud credentials. In this case here, I'll be actually deploying to AWS. So in addition to the GitHub access token, I will also include a secret for the access key as well as the AWS access secret. With my repository prepared, I'll clone my repo locally and deploy the application environment. I navigate to the relevant cloud Terraform directory and update the Terraform TFRs file. I need to add my GitHub access token, specify the correct repo path in GitHub owner, as well as provide connectivity info for my organization's analytics platform. For this example, I'll be utilizing Splunk, so I'll provide my endpoint address as well as my HEC token. With my Terraform variables updated to reflect my organization, I navigate to the scripts directory and execute the deployment shell script. The script deploys the specified cloud Terraform infrastructure and migrates the infrastructure's state information to the console server. This is done once it's completed provisioning. Once the deployment completes, I am presented with links to the various components of the infrastructure, including the sample application page, which includes scaling status as well as cluster count information. The console server hosts metadata supporting scaling operations, as well as infrastructure state information. Additionally, I'm able to see my recently deployed application via the AWS console. With my deployment complete and the metrics being sent via telemetry streaming to my third-party provider, Splunk in this case, I can configure scaling alerts. When an alert is triggered, a web call is sent to GitHub Actions via the Alert Forwarder service. The GitHub Action workflow, in turn, triggers and uses Terraform to update the application infrastructure. To see this in action, let's first review my application page and note the current cluster count and scaling status. The solution repository includes guidance and sample alerts for some of the popular analytics vendors. From the Splunk directory, I'll scroll down and copy one of the sample alert queries. From the Splunk Enterprise GUI, I'll paste the query into the search bar. I'm going to tweak the event metrics, maximum big IP CPU for this example, to ensure I get a hit and an alert is triggered. I'll save the query as an alert and fill out the various parameters. For the trigger action, I'm going to specify a webhook. And in that webhook, I'll specify the alert forwarder's endpoint as the destination URL. With the alert saved and active, the scaling solution is now operational. In this specific case, anytime a big IP cluster member or members utilization, CPU utilization that is, increases over the set threshold more than twice in a 15-minute period, the cluster will scale out. Worth noting, the repo's guidance also includes sample alerts for scaling both the big IP and workloads, either in or out. I can view workflow and scaling activity from the repository's Actions page. During the setup job, the workflow will perform several checks. It'll validate the incoming payload, query the console server for current cluster status as well as count, and verify that the cluster is not currently in a cool-off period. Taking a look back at the sample applications page, I can see that the scaling operation is now currently reporting as active. With the workflow jobs complete, I'll return to the application page where I can see the operation has completed and my big IP cluster now has increased to 2 instances. For additional information and guidance on the solution, please visit the repository listed on the screen. Thank you very much.